Oh, oh, that might be the hottest thing I've ever touched in my life. Hello, welcome back to More Fun Fixing It. Look, not every video is going to be a repair, and this one might not be, but it also might be. But I do want to talk about some things to do with repairs that have happened this week or have come to my attention this week, which I think are important enough to share with all of you. And it's specifically around Commodore 64 repairs this time. Something I haven't done for a little while. I've been a bit ZX Spectrum heavy, so let's get on with some Commodore 64 repairs. Now, this one on my workbench here is fully working. Well, I hope it is. Let's just make sure it is. Yes, right, that's fully working. And it's got plugged into it this cartridge. That is a C64 Analyzer Cartridge V2. That's one of the things I want to talk to you about. But the other thing I want to talk to you about is the Commodore Repair Toolbox, which has been brought to my attention this week. And this is a project by Dennis, who goes under the name of HovKlan. I think Dennis is from Denmark. And this is something that he's put together himself, which has lit up my enthusiasm for what is possible in a community. In fact, I've invited Dennis to be a creator on the Retro Hardware Discord, and if you are interested in helping out with this project after I've shown you what it can do, then the best space to probably do that, apart from GitHub itself, which is what I'm showing you here, is going to be on the Retro Hardware Discord. Actually, I can show you there. Look, if you go to the Retro Hardware Discord, and once you've clicked on the button to prove that you're human, you will find the Commodore Repair Toolbox in the creator channels, and in the pinned messages is this message here. If you jump to it, you'll get to this message here, which is all the links that you need. And there's a good discussion going on in Discord about it, and people are already starting to add to it, which is very exciting. When you see what it is all about, you will agree, I am sure. What you need to do first is download this from the releases page. It's just updated yesterday. And download this Commodore Repair Toolbox zip file and install that, or copy it into a place where you feel comfortable keeping it, and you'll get this set of files. Run the Commodore Repair Toolbox. It'll probably come up saying, are you sure you want to run this? I don't think Dennis is trying to steal our information, but that's a risk that you're going to have to take. And then you get this. Now, it's on Commodore 64, but there's also the VIC-20 and the Commodore 128 are included in here. But I'm going to concentrate on the Commodore 64 for now, because that's what I'm repairing. If you look on the right hand side, you've got the board layout file. So there's the original board layout there. All of these are active links, so you can click on any of these chips and it will take you to further information. I'll come to that in a second. The original board layout is here from the service manual. And this is a recreation. I believe this is BWax. I think this is BWax. It should say down here actually. Yeah, BWax created the this information. So we've got the top of the replica of the top and the replica of the bottom. We've got the schematics page 1 of 2 and schematics page 2 of 2. So again, I can click on any one of these chips. So any of these DRAM chips, or the RF modulator, or the SID chip, or one of the ROMs, or whatever I want to click on there, or on this page, or even on here. I can click on the legs of the chips from the other side, the connector for the cartridge port, the power switch. Everything is a link. The game ports, everything. And if I go back to the board layout, so for instance, if I want to know what the pin out of the power connector is, I can just click on this link and I get a brilliant page come up here showing me the male and female side and what all of them are. Now, when I'm doing repairs and I can't memorize every single pin out of every chip and every connector and every switch. They all just blend into a big mush in my brain. I have to go looking at these things on the internet, and I will end up on Zimmer's, which has been and still is one of the best resources for Commodore 64 information for retro repairers. And I will end up on there looking through schematics, and to be brutally honest, I find that list of schematics on the Zimmer's page, it's comprehensive, it's also confusing. Sometimes I'll be looking at the wrong one when, or an earlier version of one, or there's a better version out there. For instance, BWAC's schematics for the 250407 are the chef's kiss of schematics that you want to be looking at. They are perfectly clear, modernized, and not, I mean, that's the level of detail you're going to get from the original service manual, because there's scans of scans and the data has been, let's say, compressed. A huge shout out to PCBWay for sponsoring the channel. One resource I don't talk about enough is the PCBWay community and their shared projects page. Before you spend hours designing a mod or a fix from scratch, check there first. There are thousands of open source designs uploaded by other fixers. For example, if you're working on a Commodore 64 with a broken SID chip, you can find the SIDKit Pico right there, ready to order. Or if you're battling with an early Sinclair machine, you can grab the Happy Little Diode ZX Spectrum Issue 2 UV mod. It's the perfect fix for those stubborn video tuning issues, and you don't even have to design it yourself. Chances are someone has already solved the problem you're facing. You can order these projects directly from the page with just one click. It saves massive amounts of time, and you get to do the fun part of the repair faster. Check out the link below to see what the community has built. Thanks to PCBWay. Cheers. So for instance, if I need to know the value of a component, I'll have to go looking up the color codes on a resistor on here, or try and find it in a schematic somewhere. Let's actually take this as a good example of what you want to do. So these three resistors over here. Right, so if I click on one of these, we get this window pop up, and it shows you here clearly that R44 is a 3K3 quarter watt 5% resistor, and it gives you a little bit of information there as well that they're non-polarized. So that's, for a beginner, this is valuable information. Same with capacitors. It shows you some, interesting information that the long leg is the positive and the striped side is the negative. And this is a 10 microfarad 25 volt electrolytic radial capacitor, and that they must be put in the right way around because they're polarized. And that this big old chunk over here is a 1000 microfarad 25 volt. That's great, but what about inductors? An inductor will show you the 2.2 microhenries. What else have we got on here? We've got voltage regulators, and we've got transistors. There's a transistor here. That's a 2SC1815 NPN transistor. Compatible part number. Now all of this will be updated and added to, so more relevant information will be coming for this. We've got this one over here. Where is it? That one, the second one here. This big old chunky transistor here that I always used to think was a voltage regulator, but it's not. It's a transistor. It's a 2SC185 NPM. I actually thought that there was a pinout for this one on here, but maybe not. 7805 has got its pin out there. So a lot of there is still information missing off of this, but there is a lot here. So for instance, let's have a look at the CPU. This is where things get really exciting for me, because the CPUs, or all of the ICs on the C64 and on the C128 have these down the bottom, which is the traces for each pin. So if I don't think, it would be nice if you could click on the pin and it would just take you to whichever one it is. But if I scroll up on my mouse wheel, I can cycle through all of these. So pin 3 is IRQ on the PAL, and it's pulsing, and it shows you all of the data that is that you get on an oscilloscope. And this is all of the traces on a healthy C64. So if you've got a C64 that isn't functioning correctly, you can, if you haven't got a second C64 that you can scope at the same time, and I've done that multiple times to track down a problem. I've gone through with 2 probes and scoped each pin twice, well, one on each computer, to show the same traces to find out where the differences are. This will show you. This will show you straight away. This is actually really exciting. So the SID's here, and that's got all of its stuff going on there as well. And the PLA, because it's always the PLA. Oh, it actually shows you 2 different PLAs pinouts there. Don't know why it does that. Not sure what this is about. But that's the one you want to take notice of, because it's got the things like ROM H and ROM L, or ROM high and ROM low, and the chip select lines for the ROMs here and that sort of thing. These are the things you need to know. So like 15, 16 and 17 are going to be very interesting to me, because like 15, 16 and 17, ooh, just high on that one. It's the basic ROM. That's what they look like. And that's useful information. And then I can turn on my scope and I can go to pin, where was 15? I would like a back button to get straight back to the image, or to keep this image on screen in here. That would be nice. So we're looking at 15, 16 and 17, right? 15, there we go. That looks very similar. And 16, again, very similar. And 17 should just be there. That perfect. Let's go. Let's keep going up this side. 18, 19. Oh, I've gone one too far. 19, 20. Oh God, my mouse keeps jumping ahead. 21. I think my scope is set up slightly different to the scope that there was taking these readings, but look, that's perfect. That's exactly the same. 22 is the same. 23. Oh, 23. Ooh. Am I on the right pin? I found a different one. XROM. 23, 24, 25, 26, 27. Oh no, I'm on the wrong pin. Let's go up to the top and work our way down. So 28 should be just high. 29, no, 27. Oh, it might be because I've got this. 27. Very different to me. So I'll have to find out whether that's a problem. 26. Maybe it's just because I'm zoomed in too much. Yeah, it's going to be that. That's more like it. What is his time base? 200 microseconds. Let's go to the same time base so we get a better. Yeah. So that's 26, 25. Right, so that's 1,000 microseconds. Not everything is going to be equal. Yeah, every trace is, you need to look at every trace in a slightly different way. It's a work in progress, and if you look at, for instance, the VIC-20, and Dennis is a Commodore fan, so these things are what he is aware of at the moment. So we've got the VIC-20's chips here. This is the VIA, but it hasn't got any traces, so these need to be added. But the 128 is all there. The schematic is all there, and all of the chips are there, and all of the traces are there for the C128. I could have done with this a couple of years ago. So that is really exciting to me. That's going to make my life so much easier. And there's already, I know Rabs on the retro hardware Discord is already looking to add the Amstrad CPC range of computers. Or I think he's putting the CPC 464 data together to put in there already. I would love to see the Spectrum added to this. I would love to be able to have this resource all in one place, so I can just click on it and find what I need to find. If I need to know what the pinout is on the power switch, look at that. Shows me which side is 9 volts and which side is 5 volts and exactly where everything is. Absolutely amazing. The expansion connector, all of the pinout for the expansion connector. Even the LED is on there. This is absolutely amazing. Nothing for the keyboard connector. I'm surprised. Resistor packs. 3K3 network. The RF modulator. We've got the traces for the RF modulator as well. Oops. That's one thing. The other thing is this thing. Now, I first of all plugged this into a faulty machine, and it gave me an instant diagnosis, and I thought, this is amazing. This is the best thing ever. And it is great. I bought this from Uni64, uni64.com. And it's the C64 Analyzer Cartridge V2, which is €59.95. I bought this with my own money. Matthias has kindly sent me some other bits. He actually sent me another public domain SID and some other bits and pieces, another SID board for my C64 ATX build. But I paid for this with my own money, so I'm going to give you my honest opinions about this. And I always try to give my honest opinions, but you know, bias does factor into everybody's opinions in some way. When people are nice to you, you say nice things about them. Now, this is brilliant. It's amazing, and it was the initial thing that I was interested in from the uni64.com site, and the reason that I reached out to Matthias. And what intrigued me about this, and what is amazing about it, is that all of the C64 diagnostics and other diagnostics that I've used for other systems as well, so far has been ROM based. So you plug in a Des Test switch or the Sven Peterson Diag 64 cart, and you are running the code from this ROM on the computer. If the computer is really faulty, no amount of clever code, sorry Matt, but no amount of clever code will allow you to diagnose that if the screen can't display that. Matt has made amazing advances on this in actually getting the thing to actually display some kind of data, even if there is, like, the system is really badly trashed. But if, like, the CPU is completely missing, nothing's going to happen. Or if the VIC2 is not there, nothing's going to happen. Now, this thing has a microcontroller on it. It has, I'm not sure which one it is. It's got a Raspberry Pi type of Pico controller on there, either a 2040 or 2050. I don't know if it says on the web page. I can't see it. And this doesn't need the computer to be running or capable of running code. This thing, even if, actually, I'm going to, right, you can see the computer is running there. I'm going to just take the VIC chip out. The VIC2 chip, sorry. Right. And it's still going to run because it's powered and it's its own computer. And if I hit system check, that's checked that the reset is okay. And the 8701, which is this part of the circuit, the clock generation part of the circuit, is bad. So it knows that something's bad in this area. So it's stopped at that point. Now, one thing that I would like this to do, if it was possible, is for it to continue running the rest of the tests, because it has a list of tests that it runs through. I'll show you those. So it does, after the computer is booted, I do system check, reset, it does 8701, it does then the VIC, and then the CPU, then the PLA, which takes a little while. And then it shows you the clock nanoseconds. The RAM tests happen now. You can see that it changes some stuff on the screen to do the RAM tests. And that's passed. And then next is the kernel ROM, the basic ROM. Then it'll be the character ROM. And then the color RAM. And the CIA1, CIA2, the SID, And I think that's done now. Yeah. And if it fails on one of those tests, it stops at that point. So, for instance, one of the early ones is the PLA. Let's pop the PLA out. Now, obviously, we've got a black screen. This is a typical use case for a broken C64. The PLA is missing altogether, but it's still tested that the reset is okay, that the VIC2 and the 8701 timing circuit is okay. The CPU, it's tested the CPU is okay, but it's realised that PLA is bad and shuts down the test. I would really, really like it if it then continued and ran the RAM tests and the ROM tests at least, and the CIA tests. That would be really good, because there's often multiple chips that are bad in this. Now you can see on my workbench that I've got lots and lots of broken C64 chips here. I've got loads of CIAs. I've got loads of PLAs here. These ones are just broken. I'm not sure about those ones. Oh, that one I discovered is a working one. And I've got some VIC2 chips here, some ROM chips, and a couple of CPUs. I've been plugging these in to this board one at a time to find out what this does with each of these chips, and some of the results have been interesting. So if I take this, my C64 test board, this socket, the PLA socket, is so sloppy I can just take the chips out like this, but it still works, and I'm not putting a ZIF socket in there until, make sure that's off, until it stops working. Right, so this one is a faulty PLA. And if I turn this on, we get, what do we get on screen? Nothing on screen, but there is a line down the side. At this point, I would be saying, oh, right, okay, the VIC's working because I'm getting a display, but I would know nothing else about this. Now, if I run the system check, reset is okay, 8701 is okay, VIC is okay, CPU is okay. So I've already got lots more information, and it's going to get to the PLA, and it says it's okay. But the PLA in this has failed in such a way that it's actually affecting something else, and we'll explore that in a second. The RAM is okay, the kernel ROM is okay, the basic ROM is okay, and the character ROM is okay. The color ROM, oh, it's saying the color ROM is bad. Color RAM is bad. What? So we go back to the C64 Toolbox and look at the color RAM. Actually, I wonder if the color RAM is. Oh, one thing that would be amazing, and I don't think it's going to be very easy to do, is, for instance, on a schematic. So let's have a look at the PLA and see if it is connected. See, I don't know whether my knowledge doesn't stretch to the level of, is the PLA connected to the color RAM directly, and how could that be affecting it? So I would then need to look at the schematic. Right, it's showing me in the schematic, here is the color RAM, and I want that and the PLA, which is U18. No, it's not. It's U17 selected. Now I can see quite clearly that they are not directly connected. Oh, hang on. Okay, WE on the color RAM, pin 10 on the color RAM, pin 13, GRW. So now I can look at pin 13 on here. Zip up to pin 13, and it should be high, and it's low. Yeah, pin 13 is low. Interesting. So that failed in a very, very specific way. That took out the. I had a display then that took out the color RAM. Oh look, I have got a display. Also got quite a hot PLA. Right. So that's one chip that I found interesting. There's many of these chips here. So for instance, ROM. I think ROM low is what fails on this one. So if I run this one, there's another PLA that doesn't work. If I run the system check and let that run through, I'll skip ahead. That just comes up PLA bad, but here in the display, you can see in yellow it says IO2 is low, which is different to what I've written on there. Oh! Oh, that might be the hottest thing I've ever touched in my life. I have honestly burnt my finger on that. That's 82 degrees now and dropping rapidly. Ow! That's a bad PLA. Ugh. Oh, what a shocker. Okay, so I'm going to put a good PLA back in there for now. And I could show you lots of different examples of the CIAs and the CPUs. There's one CPU here I think actually tests as good, and the ROMs where the test runs, it picks up the wrong thing. So on many PLA tests, actually I'm going to show you, I think I've marked some here. This one here, if I run this one, I'm going to keep my finger on this now. If it starts getting really hot, I'm taking it out. And if I run the test now, God, I can't believe how hot that was. PLA is okay. Now it's going to come up, I think it's going to come up as faulty RAM. Yeah, it's come up as faulty RAM. And the PLA can make fool the system into, or a bad PLA can fool the system into thinking that there is faulty RAM. One thing I haven't done is actually put in different RAM chips in this. I've got lots of RAM chips that are faulty that I might try at some point. But the point is that this isn't going to be able to give you a comprehensive and 100% accurate answer. If it plugs it in and says the PLA is bad, what it's actually saying is the PLA is appearing faulty and there might be different reasons for it. And at that point, you should then use things like the Commodore 64 Toolbox. No, what is it called? I've forgotten what this is called. The Commodore Repair Toolbox. You should use things like that, resources like that, to then try to pin down exactly where a problem is using an oscilloscope. And I know that people say, oh, I haven't got an oscilloscope, but honestly, get yourself one of these, because that will do everything you need. If you are just starting out in retro repairs, that should be one of your first purchases. It's an absolute essential. It's a multimeter as well, so there's very little excuse. There's you know, it's a little bit more money, but it's not a cheap hobby. You're going to have to face that eventually. Now, I'm going to take this one off the bench and get rid of all of these broken chips, because I don't think they're serving any useful purpose anymore. And I've got 3 broken Commodore 64. I've got 4 broken Commodore 64s, including a special one over here. And I'm just going to plug them all in, and we might try to fix one of them today. This chip that burnt me is going straight in the bin. That's an evil chip. But yeah, let me get all of this off the bench and I'll bring up a broken Commodore 64 and we'll see how that turns out. Oh, and by the way, it's not always the PLA apparently. I had more broken SIDs than broken PLAs. Right, I'm not even going to open this one. And I did plug these in and try the tester on it, but I can't remember any of the results. So we're rediscovering this together. Let's pop the analyzer cartridge in. I need to print a case for this because it's a bit difficult to get in. Oh, and this isn't the only thing this does as well. I should point that out. But let's run the test on this one first, and then we'll quickly go through the other tests as well. So reset is okay, 8701 okay, VIC okay, CPU okay, PLA, I think this is okay, this one. Clock is good. RAM, I think this, I've written bad SID on here, is okay. Oh, it's got a bad, oh no, that's the That's the RAM test running. I thought that was a bad screen. Kernel basic and character are okay. Color RAM is okay. CIA, okay. CIA, okay. And SID is okay. So this one is actually working. It just needs a new SID. That was a bit boring. Let's find something a bit more broken. All this says is power white screen, case very nice, no broken clips. I've not even opened this. Right, so this is the screen that we get. Oh, it's not a white screen, it's more of an orange screen. And if I plug in the normal diagnostics, this is a normal diagnostics, the one that you run with the test harness, nothing, black screen. If I run, I think this is either Des Test or Max or Dead Test. I can't remember which way around I've got them. But nothing, I'm not getting anything from any of these. I will even plug in Des Test switch. And that's all that does. Let's reset it. It's not having any effect at all. Okay, so let's take that out. What does this think? This is a classic. And the other good thing about this is you don't need a screen attached. It will actually work without it. So if I run the system check, reset is okay, 8701 is okay. VIC is okay, CPU okay, PLA is okay, clock is okay. RAM is bad. So this could be bad RAM or it could be the PLA. It's more likely to be the PLA, but if we look inside, it might have empty RAM in it. That's a good idea. Or it could be the multiplexes for the RAM that are bad, but it gives you a really good idea of, or it actually tells you the things that are good. So it can have false positives as well. So it can tell you that a PLA is good or a ROM is good or a CPU is good when it does have a marginal fault. So that's one. This one's quite interesting. It even says, interesting. So we turn this on, get a red screen. Let's go through the other tests again. So normal diagnostics first. Nothing. And then I think this is either Dead Test or Des Test, nothing. And Des Test or Dead Test, nothing. And Des Test switch, nothing at all. Reset isn't doing anything. So C64 Analyzer V2. And run the test. Reset okay. 8701 okay. VIC okay. CPU okay. PLA bad. It's just a dead PLA. Can look inside this one. Look at this. DOS 5.7 Turbo and DOS 4.7. Very cool. I like that a lot. So this might have been causing me a lot of headaches trying to fix this one, but it's like this usually is the PLA, and knowing that this has now pointed to it, I can now take this and scope out the different lines and find out exactly what is going on with this using the oscilloscope. And it will target what I'm doing much more precisely onto areas of the board that I need to be looking at. So I don't need to worry about the VIC2, although I will inspect in case it's got any leaking caps under there. With this one, I am concerned that this ROM board might not be making the best contact, but it feels really solid on there. No problem at all. So I can just take this out, find a way of disconnecting this from the rest of it, get that PLA out and put another one in, and it should just come back to life. That would be quite interesting. But I've got one more I want to show. My finger really hurts. God, that's the hottest chip I think I've ever touched. Oh yeah, this is all of the SIDs. ROM. This is that C64 silver label that I've been promising to fix for a long time, and I've kind of been putting it off. And I thought, I wonder what this one will do if I plug this in. Now, I can't plug in the video cable because it's the wrong type. It needs a 5-pin, and that's a 7-pin in there. But I can plug in power, and I can plug this in. I have got another video cable, I just can't be bothered. And turn this one on. And assuming that this will work just as well with this early revision board, run the system check. And bearing in mind that all of these socketed chips I've tested in other machines. And the PLA is coming up as, come on, bad. But it says ROM L8000 kernel. And the kernel ROM in here has not been socketed. So I'm fairly sure that it's going to be that one. So I'd quite like to fix this one on this episode, but I'm actually not going to do that. I'm not going to do that. It would be nice to do it, but I have got another one. Yeah, this deserves its own episode. Right, so this one is coming up as RAM bad. This is the one we looked at a minute ago, the one with a nice case. So let's open this up. I'll find out what's going on in here and see if we can spot what that is, why that is coming up with bad RAM. Oh, excellent. It's a 250407, so we're well covered in the documentation. And amazingly, it has a socketed PLA, but not a socketed SID. The kernel is socketed, and this 7406 over here that's part of the timing circuit is socketed as well. So the first thing I'm going to do is actually swap out this PLA for a good one. Got the one from my test machine here. And I kind of suspect that this will be the problem. I don't think that's MT memory in there. I think it's NEC memory, and that's really reliable. This could actually be an interesting fix if it's not the PLA. But I'm going to give it every chance by giving it some of my Phil Sands branded contact cleaner. I'm just going to try plugging it in and turning it on. Wasn't that a white screen? Yes, it was the PLA. It was the PLA. So we've got a very bad PLA there. I'm just going to... Oh, that's... I should show you the other things that this does. If I go up on the menu, it shows you these signals that are available to it on the edge connector. It just shows you a little display of them. The other thing it can do is short circuit check. I think I need to plug this in so it's powered. Go down to short circuit check, and it will check the, it's not powered up, but it's checking the pull-up resistors to make sure that they're okay. There's no short circuit. That's probably a good thing to do to start with. This is actually connected to my PC. There's a website, there's a link on the Uni64 page, which if I connect this to this device, this web page connected to this device now, and turn the, oh, actually, it's not, I have to put it onto USB OSCI. That's running now. If I connect that, come on, connect. Oh, I must have already connected it. And then turn on, yes, then turn on the C64. It shows you a scope trace of every single address line, all the data lines, lots of the other interesting lines that are available on the edge connector. And I've seen, I've put in a faulty PLA in one of the machines which had ROM L was low, and it was difficult to tell whether it was high or low. So it would be nice, you know, the representation of this is tricky to see, but it's nice to be able to see that, you know, the computer is running from this. I'm not sure how much utility this has. There was another CPU that had all of the address and data lines were all in unison doing exactly the same thing. So it's obviously just crashed and just pulsing the same thing over and over. Shows you the clock there and that the reset is there. If I turn it off and turn it, yeah, reset goes low and then goes high. So that's a really nice graphical representation of it. So that's nice, but what else can it do? It does a boot check. So if I hit that one, it's actually running a boot check. Startup error. Oh, all right. Really? Boot check checking. Oh, right, it come up okay at that time. I'm not sure, I might have done something wrong there. Let's just run that one more time. So what it's doing now is running through the opening sequence of when the computer starts up. I'm pretty sure it just, you know, in the background resets the computer. And has a look at the instructions that are being executed and compares them to a known good boot up and shows you if there's any differences. I think that the thing I'll be using this mostly for is this system check. So we'll just let this run through and see if it pulls up any other errors before I then connect it to some other diagnostic tools. Everything good so far. RAM is okay, kernel's okay, basic's okay, character ROM is okay, color RAM okay, CIA 1, CIA 2, and SID is okay. Okay, that's not the whole picture though, because it, like I say, it's not a comprehensive tester. You need to use it in conjunction with other testers like this one. So I'm just going to run the normal diagnostic. I should really connect. Yeah, let's connect the test harness. Those contacts didn't look good, so I gave them a quick clean up. I'm just going to contact clean or spray contact cleaner into all of these before I put them into the edge connectors and sockets, just to one, to lubricate it, but also to give it every chance of making a good connection. Especially this one. This one needs the extra lubrication because it's super difficult to get this one on and off. Good grief. Okay, let's run that one. And whilst this isn't a gold standard RAM test, this in conjunction with the DesTest cartridge will cover everything that I think you need to do to test a computer, apart from possibly the SID. I know Mark from the Retro channel likes to run different test programs. I haven't tried to get access to those test programs for testing the SID, and he's more of a discerning ear than I am, and I'm happy to just run it and make sure that the is working. I can't actually hear that at the moment because it's recording on my PC. So I'm gonna you'll have to tell me if this is working, but I'll listen to it in editing and make sure it's okay. But that looks like it's a full pass on that one. And the only other thing I would like to do on this is just to run DesTest switch on it, like so. Walk away and come back and make sure that that has, because it takes a while because it's such a comprehensive test, that's done at least one pass on the RAM. So I'll be back in a minute. Hey, right, so if that's passed one loop of DesTest switch, then the RAM is good. Now you can just leave that running, and I probably will, if I get time, just leave that running. But one more thing I want to do before I say goodbye is to put that bad ROM back in and have a look to see if we can see where it's bad and compare it with the signals on the Commodore Toolbox. No, it's Commodore Repair Kit. Commodore Repair Toolbox. I know what it's called. Just trying to get this off. It's really hard. There we go. Oh, I don't need to put that in. Okay, let's take the good PLA. I say good, it's got tiny short legs on it. Put this PLA back in here. It could be that it just had dirty legs. That's a possibility. Let's just give this a little brush up. And it's a dual wipe socket, so that's a good thing. Give it a little tickle with some fiberglass. Give this another squirt. See if it turns on. Still the same horrible puce screen. Okay, so what did the test say? What exactly did it say? It said something about RAM, didn't it? Right, so it's coming up as RAM 1003 FFF. And that says 407, 425, 466, U10, 469 U10. I don't know what any of that means. So it's saying that U10 is the bad chip, which is this one down here. Maybe. I think that's what it's saying. There's one other thing I just quickly want to do. And that is having a look at this to see if anything here. So all of the data lines look like they're active. So, you know, whether U10 is one of those and looks different to how it should, but I don't think you could really diagnose this from here. Let's take that out. These are the scope. This is the PLA. That looked like that was a moving trace then. That's amazing. Okay, so we've got the PLA. I'm going to run from pins 1 all the way to 28 and see if we can compare them with the actual thing. All right, so pin 1 is low. Pin 2 is that, and that looks the same to me. Pin 3 is, well, it's supposed to be that. That's one difference. So yeah, that's broken there. Pin 4 is also broken. Pin 5 is correct. Pin 6 is correct. Pin 7 is correct. Pin 8 is correct. Pin 9 is going to be a clock. It's correct, I suppose. I'm not sure if it's a clock actually, but it's probably a CAS or RAS or something. That looks correct. I don't know what pin we're on now. Pin 11 looks correct. Pin 12 looks correct. Pin 13 doesn't look correct, but that might just be my scope is not on the right setting for it, but I'm not going to change it now. This is pin 15, that looks good. 16, it's good. 17, good. 18, it's good, I think. 19, I feel this ROM's getting starting to get a little bit warm now. 20, that's good. I think we're into the data lines now or something, aren't we? I don't know what. No, maybe not. What's this? 21, it's good. 22, probably good. 23, yep. 24, no. 25, think so. 26, yep, that is good. 27, no, probably not. 28 is just high. So now you could just go through, find the ones that are different and find out why they were different by tracing them to the other chips. We fixed this one now, so I don't need to dig too deep on this one now. It's got a completely full bill of health, full clean bill of health. You can have a full bill of health as well. And I'm happy to mark this one as fixed. I'll check the keyboard, and I need to build a GAL PLA to go in here because my PLA is needed elsewhere. And this one can go in the bin with the other one. Marvellous. So I hope you found that interesting, or as interesting as I found it, because I got very excited when I saw the Commodore Repair Toolbox pop up. I thought that that is going to be a huge moment there where things will change for people like me that repair lots of machines. Having all of the resources in one place, just mind-bogglingly useful. And I was really impressed with this. This, I think, is going to give me a really good starting point for each repair. Now, the only thing that I am concerned about with this is it's going to make things a bit too easy for me. There might be times where I will, you know, after a while I might start putting this away and not reaching for this first, because I don't want to lose the ability to work things out for myself. And part of learning how these things work is to figure out how things work together, how all of the different parts work together, and how they are affected if one part has gone faulty. And they all go faulty in really interesting ways, and it's never the same twice. But it will be, I think, Matthias, you've made a marvellous piece of diagnostic equipment there for us to use. Yeah, brilliant. Oh, it's got an SD card on there. What? An SD card slot, or micro SD card slot. I wonder what that's for. Interesting. So, fantastic. Thank you, Matthias. Thank you, Dennis, for your amazing hard work. If you'd like to help out Dennis, especially for the Commodore Repair Toolbox project, head over to Discord. There will be a link in the description, and I'll leave a link to his GitHub in the description if Discord is not your thing. And yep, I'll see you on the next repair. I'm going to go and bandage up my finger now. That really hurt. I'll never be the same.